In this session, let's look into the last part of probability, that is nothing but Bayes theorem. Now, what is this Bayes theorem? Now, Bayes theorem basically talks about the law of total probability. Now, what is this law of total probability? Now, Bayes rule, whatever we have as a Bayes rule or a Bayes formula, it completely based on the individual probability over the total probability. That's what we are going to talk about, the law of total probability. Now, let's understand what is this law of total probability. Let us take out E1, E2, E3 and it goes on up to En are mutually exclusive and exhaustive event. Now, what is this exclusive? Mutually exclusive means those two don't have any common factor. And what is this exhaustive? Exhaustive means sum of all the probabilities is equals to 1. Now, if those events are mutually exclusive and exhaustive and connected to a random experiment, so now these things are connected to an experiment with a sample space of S, then X which has any occurrence that involves any of these events can be given as probability of X is equals to probability of first event times the probability of X given that E1 has already occurred. Similarly, probability of E2 times probability of X where E2 has already occurred. So now this can be taken as a summation of I equals to 1 to n for all the values, probability of event, any event which is I, times probability of a given question or probability of a given occurrence which is X over EI. Now this has to be taken for all the values. This is nothing but the law of total probability. And you can also see here, we have clearly mentioned the most important points here about mutually exclusive. Mutually exclusive is that event for I and J if those two don't have any intersection. Next one is exhaustive. Exhaustive is when probability of all the individual events or probability of sum of all the individual events is equals to 1. And next we have one more important point, that is equiprobable. It means probability of all the events is going to be equal. For example, when we are going to roll a dice, there is a equal chance of getting 1, 2, 3, 4, 5 and 6. So I can say probability of getting 1 is 1 over 6, probability of getting 2 is 1 over 6, or probability of getting any number over there is going to be 1 over 6. This means it is equiprobable. Generally, when we talk about a random experiment or unbiased experiment, at that time we are going to take it as, or we are going to consider equiprobable events. Now let's try to understand Bayes rule. Now let's see what is this Bayes rule. Now in the previous case itself, while explaining the law of total probability, I have given you a glimpse about Bayes rule, isn't it? What is this Bayes rule? Bayes rule talks about the individual probability over the total probability. Now let's try looking into this. Now if I'm talking about E1, E2, E3 and En, where these are the events which are mutually exclusive and exhaustive, and also P of E1, or it means that probability of any event is greater than 0 where I is lying from 1 to n. Then I can say probability of EI is called as prior probabilities. Probability of any event is called as prior probability. So we have a list of events, so in which if you're going to take out individual event, that is called as prior probabilities. Now suppose an experiment results in an outcome of event X. Now we are talking about an outcome X where probability is greater than 0. That can be solved using a conditional probability, and these probabilities are called as posterior probabilities. So which is nothing but probability of E1 given X is there. Now, given by the Bayes rule, I can take out probability of event E1 or any event is going to happen. Given that an observed event has already happened, it is given by probability of that individual event, which is P of E1 times probability of X over EI divided by the total probability, which we have already seen in the previous case. So it's nothing but summation of I equals to 1 to n probability of E of I times probability of X over E of I. So this is nothing but a Bayes rule. This is what we are going to apply it throughout for a mutually exclusive and exhaustive event. Now let's try to understand Bayes theorem with the help of an example. Now in this question they have said that a laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. Now they have said that it is 99% effective. However, the test also yields a false positive result of 0.5% of the healthy person tested. And they have also said if 0.1% of the population actually has a disease, what is the probability that a person has a disease given that his test result is positive? Now let's try to understand this by taking out the points one by one. Now let's talk about two events. A person is having a disease and person is not having a disease, which will take it as E1 and E2. And let A be an event that the result is positive, because they are going to ask us a person has a disease which is nothing but E1 and the test result is positive, which is A. So we need to find out probability of E1 given A. This is our final thing. Now, in order to find out probability of E1 over A, if you are going to use Bayes theorem, I can say probability of E1 times probability of A over E1 divided by probability of E1 times probability of A over E1 plus probability of E2 times probability of A over E2. This is what we need to find it out. So now let's try to find out one by one. Now E1 is person having a disease. Now they have said that 0.1% of the population actually have a disease. So I can say probability of E1 is 0.001. 0.1% is nothing but 0.1 divided by 100, which is nothing but 0.001. Next, let's talk about one more thing. A person does not have a disease. If 0.1% of the people is having disease, then 99.9% of the people does not have a disease, which is nothing but probability of E2 is given by 0.999. Next, they have said that a test result is positive and a patient is ill, which is nothing but 99% effective. 99% effective is test result is positive and a patient is also ill. So it is nothing but positive is P of A given that patient is ill. A given E1 is going to be 0.99. And now a test result is positive, person is not ill. That is going to be 0.5%, where I can take it as 0.005. Now, if you're going to substitute all the values in this particular formula, I'll be able to get the final answer. Now, let's try looking into the substitution and we'll find out the final answer. Now, you can see here, P of E1 is going to be 0.001. So, we are going to write that 0.001 here. Probability of A given E1 is 0.99. I can write it as 0.001 times 0.99, which is going to be 0.00099. Now, same thing we are going to write in the denominator plus probability of E2, which is going to be 0.999. That is being written here times probability of A over E2, which is going to be 0.005. If I'm going to multiply it, I'm going to get it as 0.004995. Now, if I'm going to add this, I'll get it as 0.005985. In order to simplify it, I can take it as 990 over 5985, which can be simplified as 22 over 133 as the final answer. Now, I hope it is clear. Here you need to understand they have given two events with respect to one more. So looking into this, we can say that we have got either this or that, and I can also say that it is exhaustive because if E1 is an event which says a person has a disease, E2 is an event which says person doesn't have a disease. So there are only two options, 0.1 percentage, so remaining is 99.9 percentage. We have taken the total population. That is nothing but exhaustive. Now let's try going out with one or two questions and let's try to understand it clearly. Let's have a look into the first question here. It is reported that 60% of the college students live in dorms and 40% attend classes on a day-to-day basis. According to the statistic from the previous year, 20% of the day scholars and 30% of all the students living in dorms receive a A grade in their yearly exam. What is the probability that a student who receives a A grade at the end of a year is selected at random from the college is a hosteler? Now let's try taking out the conditions here. I'll take out event E1 where the student resides in dorms. That is nothing but student is residing in a hostel. Next, remaining student, that is nothing but B2. That is nothing but event 2. Event 2, I can take it as a day scholar. And I'll take it as a event A, which says that a student have received a A grade. So I'll take it as A grade. Now what are the points they have given? They have said that 60% of the students live in dorms. It means that probability of E1 is 60%, or I can write it as 60 over 100 or 0.6. Next, if 60% live in hostel, then I can say probability of E2 is going to be 40%, which is going to be 0.4. Now they have said that 20% of the day scholars and 30% of the students living in dorms have received a A grade. It means they have received a A grade and a person is staying in hostel is 30%, or I can write it as 0.3. Similarly, probability that a person has got an A grade provided he is a day scholar, which is E2, is given as 20%, or I can write it as 0.2. Now they have said that a student is selected at random from a hostel or a dorm and he has got A grade. It means that we have to find out probability of hosteler is going to be E1 and he is going to receive A grade. Now again, we can apply a Bayes theorem over here and we can easily solve this problem. Now according to Bayes theorem, it says that probability of E1 over A is equals to probability of E1 times probability of A over E1. A given E1 divided by probability of E1 times probability of A given E1 plus probability of E2 times probability of A given E2. Now if you're going to look into this, we have got all the values, which is going to be 0.6 times A over E1 is going to be 0.3 divided by 0.6 times 0.3 plus 0.4 times 0.2. Now if you're going to solve this, 63 times 18, 0.18 over 0.18 plus 0.08. So I can get it as 0.18 over 0.26, which can also be taken as 18 over 26, or I can also say it as 9 over 13 as the final answer. I hope this is clear. I hope this one question and the previous example will give you a clear-cut idea about a Bayes theorem, and I hope it will help you out in understanding and solving the problems on Bayes theorem. This completes our lesson on probability, and please make sure that you're going to recall the points related to the Bayes theorem and all the different conditions of probability so that it will help you out in answering all the questions related to probability. Thank you.